Hello, Sophia. I am ready to do this problem. The problem about the infected persons and an estimate from New York. Well, first you got to figure out what type of sequence you have. Okay. First, the sequence. If the way I thought through it, if you have one person affected, and I can spell most days. Let's erase that. That didn't look good. So let's put one person can affect how many people? I'm going to put 1, 2, 3 people. This is how my brain thought about it. 2 people can affect, well, that's 3 people. 2 people can affect, well, now you got 3 people affected. So I got 3 for the first person. So that's 1, 2, 3. 3 for the next person. 1, 2, 3. And 3 for that person. 1, 2, 3. That's 3, 6, 9. 9 people affected. Well, let's go to the third. Well, 3 people. Well, each one of these are going to affect 3. So that's 9. So that's 9 times 3. I could draw the circles, but I don't want to. So that's going to be 27. Get the point? We just multiply by 3 every time. So 4 is going to be 27 times 3, which is 81. So we got to look for a pattern and an equation in reference to the original number. That's how I think about it. So far we have 3 to the 1 power. The next one is 3 squared. The next one is 3 to the 3rd. Get the point? 3 to the 4. Continue, so forth and so on. So if it's 10 people, that's 3 to the 10th power. Or you can write that as, and then you have to add up all these values. So you can write this as the summation from I equals 1 to n of 3 to the I power. Could have said n, but I'm going to use I. Same idea, because I use I equals 1. Or I could have put n. Either one's okay. But I need to sum up this finite sequence here. So I'm going to rewrite this so it looks like something I'm used to. So I can rewrite 3 to the I power as 3 times 3 to the I minus 1. See, how can I do that? Think about this. This is a 1 power here. Well, if I go 1, if I multiply powers, 3 to the 1 times 3 to the I minus 1, just add them. The negative 1 and 1 is going to cancel because you're adding the exponents. So this is the same as 3 to the I. But this, I have a formula for to find the sum of that sequence, which is really important. So let's pull that up here. And this is just a little chart here that gives you the sum of different sequences. Notice this one here. This is a to the n equals a sub 1. Well, my a sub 1 is 3. My r is 3. And my n minus 1, this is my geometric sequence, which we've been doing for 100 years. I'm exaggerating. So now the sum of this finite series is calculated by this formula here. That's the formula we're going to use, which is equal to a sub 1 times 1 minus r to the n power all over 1 minus r. We know r is 3, so let's plug in what we have. So I'm going to have 3 times 1 minus 3 to the n all over 1 minus 3. That's my formula. Now, this is, we need to set it equal to 80% of the population of New York. And the population of New York, which they gave me in the problem, was 8,400,000. So you're going to take 8,400,000 and then just multiply it times 0.8, which gives you 80% of that population, which happens to be 6,720,000. And now this is what I have to take and solve it for n. And since I'm out of space, I'm going to go over to the next slide. So I have 6,720,000 set equal to 3 times 1 minus 3 to the n over 1 minus 3. And I just got to solve this for n. No problem. Let's see. Do the math over here. Divide by 3. If I divide both sides by 3, I'm going to get 2,240,000 equals 1 minus 3 to the n all over -2. Great. Let's see, what can I do next? Let's clear that fraction, multiply by -2. Bam. I get -4,480,000 equals 1 minus 3 to the n. Subtract 1 on both sides. That's nice. That's easy. -4,480,001 equals -3 to the n. Almost there. Divide by -1 because I'm going to get the 3 to the n by itself because I can use my logs. So now you're going to have 4,480,001 equals 3 to the n. Several ways to solve this, depending on how you think about it. I like taking the log of base 3 of both sides. So I'm going to say log base 3 of 4,480,001. That didn't come out good. Let's go back. Equals log base 3 of 3 to the n. Well, this is nice. On the right side, that just cancels. Log base 3, same base. That was the whole point of doing that. So that's going to cancel on the right. So you have n is equal to this. Type that in your calculator. You can do your change of base formula. You may have a calculator that you can type this in. But when you type this in, if you don't have the type of calculator you can type in, it's just log of 4,480,001 divided by log of 3. If you type that in your calculator, you get, where's my answer? And this is just confirmed exactly what's in the answer key. So this is 13.9404, which is about, approximately 14, about 14 years, about 13.94 years to be exact, in order for the population to reach the infected people to reach that particular amount. So that's it. Hopefully that helps. All right. See you.